Yesterday we were learning about congruent triangles, and today we need to learn about similar triangles. Similar triangles are used a lot in trigonometry, and it provides us a way of finding missing side lengths for things that we can't necessarily measure, but we can estimate based on the fact that it forms a triangle that's similar to another triangle which we can measure. So similar figures have the same shape, but may be different in size. And we talked about this yesterday when we created our 50-degree and 60-degree angle triangle. The corresponding angles are equal, and that preserves the shape. It makes the shapes the same for each figure. But the corresponding sides are proportional. Now, proportional does not mean equal necessarily. The proportionality just enlarges or reduces the size. So what happens is you could have one side being half as long as a corresponding side in another triangle. Or I could say this side, AB, is twice as long as side ED. Now I haven't measured those, so I don't know exactly that it's twice as long, but if it were, if side AB is twice as long as side DE, that would mean that the other corresponding sides also have to be twice as long. So I would take side DF and times it by 2 to get this side, or I'd take side EF, multiply its length by 2 to get this one if they were twice as long. Okay, and that amount is called a scale factor, but we'll talk about that more later. Basically what I want to say here is if triangle ABC is similar, and this time our symbol for similarity doesn't have the equal sign, it just has the wavy line. So you don't put the equal because the equal would mean congruent. If triangle ABC is similar to triangle DEF, what that means is angle A would equal angle D. Angle A equals angle D. And angle B would equal angle E. And angle C would equal angle F. So these are our corresponding angles, and they are equal to each other. That's supposed to be a curly bracket. So corresponding angles are equal to each other. But our side lengths are proportional. So the way we write that is if we took side length AB and we were to divide it by side length DE, that ratio, that division would be equivalent to taking side AC and dividing it by side DF, and that ratio would be equivalent to taking side BC and dividing it by side EF. Okay, so our side lengths are not equal to each other, but we say that our side lengths are proportional to one another. That's R, not dar. Sides are proportional I'm going to put the word corresponding in front of that. Corresponding sides are proportional to each other. Okay, now like our congruent triangles, we have some theorems that will help us prove that triangles are similar. With our example yesterday, we had two angles that were equal, so we had the 50 degrees and the 60 degrees, and everybody had those same angles, and that forced our triangles to have the same shape, but not necessarily the same side. So in this case, we've got angle A being marked equal to angle D, and angle B being marked equal to angle E. So angle A is equal to angle D, that was marked or given, and then angle B was equal to angle E, and as soon as we have two pairs of angles that are equal, we have similar triangles, marked or given. So therefore, triangle ABC is similar to triangle DEF by angle similarity. Okay, so you could start, yesterday we started with the congruency statement and then wrote down why it was congruent. Today I'm just doing it in the opposite order. I've written my reasons why it works. So this is an angle here and an angle here. And then we get angle-angle similarity there. Okay, there is another one where we have side, angle, side. Now we have the congruency, where if once we have a side equal to another side, the contained angles are equal, and then another side equal to another side, then they're congruent. In this case, we have side, angle, side, but they're not equal and equal. We don't have the pairs of equals. But if I were to take 5 and divide by 2.5, I get 2. And if I take 7 and divide by 3.5, I get 2. So they are proportional. So if two pairs of corresponding sides are proportional and the contained angles are equal, then the triangles are similar. So we can write that as angle A equals angle D. That was given or marked. And then we have, if I take side AB and divide it by side DE, I will get the same answer as if I do AC dividing by DF. So notice my sides on the top, the AB and the AC, both come from the first triangle, and the DE and the DF come from the second triangle. We want to be consistent with which triangle they come from. So that means, therefore, triangle ABC is similar to triangle DEF by side, angle, side similarity. Okay, and as I said, if we did AB and divided by DE, we would have 5 divided by 2.5, which is equal to 2, and we have AC being divided by DF, just in case you don't believe me. We get 7 divided by 3.5, which, if you check that, it's also equal to 2. So that's how I knew that they were actually equal to each other, and the sides are proportional. Okay, so flipping the sheet over, we have a third one, side, side, side. Let's get that on the right spot. If 3 pairs of corresponding sides are proportional, then our triangles will be similar as well. So looking at this, if I take my longest side here, it's the 8 centimeters, because sometimes these triangles are rotated or flipped, or they're a different orientation. So I always look for my biggest compared to my biggest, my smallest compared to my smallest, and my middle compared to my middle. That's how you know which sides should be compared to each other. If I take BC and divide it by EF, we can punch that into our calculator. We've got an 8 divided by 4, or you can use your brain. That should be a 2. And if we take side AB, the shortest side in this triangle, compared to the shortest side over here, DE, we get 5 divided by 2.5, which is a 2. And then we take the third, we have AC divided by DF, and that would be 7 divided by 3.5. That's also equal to 2. So this equals this equals this. They're all equal to 2, so they're all equal to each other. So we can write that AB compared to DE would equal AC compared to DF, which equals BC compared to EF. Which means then, therefore, that triangle ABC would be similar to triangle DEF by side, side, side similarity. So they're not equal in length. The 8 isn't equal to the 8, but their ratios are equal. Okay, they're proportional side lengths. All right, example, determine if the triangles are similar. So we have triangle ABC and we have triangle PQR. Okay, and I don't know that that's the right way to say their names, but let's do a comparison and see if these actually are similar triangles. Now I don't have any angles marked, so I know I can't use angle, angle, and I can't use side, angle, side. I'm given all 3 sides, so I need to calculate my ratios. If I look at this triangle, my longest side is AC, so I could take AC and compare it to my longest side here, which would be PQ or QP. Now, A went from the shortest to the middle. When I label this one, I want to go from shortest to the middle length. So I'm going to call this QP. Okay, so AC divided by QP. So I've got my 10.98, and that's going to be divided by 7.32. And then you can put that in your calculator. I should get a 1.5 on that one. Okay, and then I'm going to take my smallest compared to my smallest. It doesn't really matter which order we do this in, but I usually leave the middle one for last. AB, so that's my shortest, so I went from my longest, so that should match with QR here. So AB was 5.43, and I'm going to divide that by 3.62, and we get approximately 1.5. And then if I take my last one, let's go BC, and I'm going to compare that with RP. That's going to equal 8.52 divided by 5.68, and that should equal 1.5. So our side lengths are proportional. It's all a scale factor of 1.5. If I take any one of these sides and multiply by 1.5, I'll get the matching measurement over here. Okay, or conversely, I could take these measurements and divide by 1.5, and that will get me these measurements for this triangle over here. So if I look at how I wrote my letters, I was very careful when I did this. I've got AC, I've got AB and BC. So I could say that triangle, or let's write this first, AC over QP is equal to AB over QR is equal to BC over RP. So therefore, triangle ABC will be similar to triangle. So A would match up with the Q, the B matches up with the R, and the P matches up with the C. Okay, and that's by side, side, side similarity.